Hi, in this video, I'm going to show you how to perform the hypothesis testing in one continuous process. Now, in my previous videos, I explained the 5 steps in performing the hypothesis testing, and because of a lot of details were discussed there, it seems that the process is a long process. But in this video, my objective is to show you that the test of hypothesis should not take that much time. Okay, so let's start with this example, and it's the same example that I use to explain the steps in the hypothesis testing. So it is known that the average length of sleep at night of teenagers aged 15 to 19 is 7 hours. A group of students feel that this is no longer true, particularly in their school. To validate their claim, they asked 50 randomly selected students and found that their sample mean for the length of sleep is 6.38 hours with a standard deviation of 1.25 hours. Test the validity of their claim by performing a hypothesis testing using 1% significance level. So let us begin with our solution. First, we have to let mu to be the time or the true average length of sleep of teenagers aged 15 to 19. So mu is the symbol that we will use for our population mean. So with that, we can proceed with writing our null and alternative hypothesis. Now, based on the statement, it is known that the average length of sleep is 7 hours. Therefore, the mu is equal to 7. And then the claim that challenges this known data is that it is no longer equal to 7. Therefore, the alternative hypothesis is written as mu not equal to 7. Again, this is our step number 1 for the hypothesis testing. It is the writing of the null and alternative hypothesis. Now, next step is the writing of the significance level, the determining of the type of test, and the decision rule. Now, because this is a problem and it is already stated that we have to use the significance level of 1%, then the alpha is equal to 1%. The sample size n is equal to 50 because the students asked 50 randomly selected students. Take note that we don't have any value about the sigma, so the sigma is unknown. With this information, we know that the type of test to be used is a z-test, and that z-test will be using two tails because the alternative hypothesis states mu not equal to 7. By the way, in other textbooks, they name this as non-directional alternative hypothesis because it is not either a left-tailed or a right-tailed, so there is no direction. Hence, it's a non-directional alternative hypothesis. So in a diagram, we could imagine that to be, so if we have the normal curve, then later on, we will be using a diagram showing two tails for the critical region or the area of rejection. So this will also guide us in identifying the decision rule, and the decision rule is to reject the null hypothesis if the z is less than the negative z of alpha over 2 or if the z is greater than z of alpha over 2. It simply means that the value will fall on the critical region or the area of rejection that will lead to the rejection of the null hypothesis. Now, if the z-test is or will be used, then the formula to find the test statistic is given by x bar minus mu sub 0, the hypothesized mean, which is equal to 7, over the value of the standard deviation over the square root of n. So that basically is our step number 2. Then we go now to step number 3, and that is the computation of the test statistic. The test statistic that we are using here is the z based on the conditions that we have. So following the formula and the known values for these components, the x bar is 6.38, the s is 1.25, the n is 50, and the hypothesized mean 7. When we place these numbers in the formula, we have 6.38 for the x bar minus 7 for the hypothesized mean, s is 1.25, over the square root of n, which is 50. If you will compute for this number, this value is equal to negative 3.5072, or approximately negative 3.51. And that's how fast we can perform step number 3. Now we go to step number 4, and this is where we compare the computed test statistic that we obtained from step 3 to the critical values or the numbers in the diagram. Now the critical values and the numbers can be obtained by using our significance level alpha, which is equal to 1%. And that means our alpha over 2 is equal to 0.005. So the z of alpha over 2 that we need is the z of 0.005. Now we have a useful list here and says that the alpha, or the z of 0.005 is equal to 2.58. That is why we have here the negative z of alpha over 2 is negative 2.58, and the z of alpha over 2 is positive 2.58. So this will set the boundaries for our critical regions or the area of rejection. Now, if we go back to our computed z value, the test statistic, we found that to be negative 3.51. So that means this number will be in the critical region or in the area of rejection. So once we know that this is the case, we can now say that the null hypothesis is to be rejected. So to state our decision and conclusion, we have to reject the HO or the null hypothesis based on our findings in step number 4. Therefore, there is sufficient evidence supporting H1 at 1% significance level. This means that the average length of sleep of the students in their school is not 7 hours. And that is how we perform the test of hypothesis, showing the 5 steps. Okay, so that's all for this video. Thank you.